Hello everyone. So today we are going to learn with the new topic that is membership function tuning using performance criteria. So in the previous lectures we have seen that what is membership function tuning, or there are different methods in order to get a better result in adaptive fuzzy. There are different methods which are used to get the better results. Okay, so in the previous lecture we have seen there are methods such that wherein fuzzy set wherein we tune the membership functions, we tune the scaling functions, or we change the rules. So depending upon the requirement, these parameters are altered. For example, by changing the scaling function, we can change the rule execution, and thus thereby we can get the desired output. Okay. Suppose that we want to change the rules. So depending upon, suppose a certain set of rules are not giving the particular output. So what the system does is, AI type of system does is, it changes the rules which are to be executed. Okay, such that we get the better result. There is one more type of what we can say method wherein the membership functions are tuned. For example, let us say that we have a triangular functions, and the range is from, let us say temperature ranges from, so low, medium and high. Low range starts from 0 degrees to 10 degrees, medium range starts from 8 degrees to 20 degrees, and high range starts from 15 degrees to 30 degrees, let us say. Okay, now if we are not getting the desired output, what exactly the system does is, it will change the shape of these membership functions, or it will tune the system by changing the function. For example, instead of having the range of, for low, instead of having 0 to 10, it will make it 0 to 15. So now what will happen? The rule execution gets changed and the output also gets changed. So by changing the parameters of what we can say membership function, the output can be changed. So that is what we are going to study today. So the thing what we are studying here is membership function tuning using performance criteria. So we are tuning the membership function. Membership function is basically the shape of membership or the value, anything. So that we are going to tune. But the tuning is done by taking the performance of the system. For example, there are certain set of rules. Let us say that the error is one of the performance criteria. So if the error is 0 degrees, we should not do anything. If the error is 0%, we did not do anything, because the system is working at set point. Suppose that the error is 100%, so it is a large error, right? So in that case, what we need to do? We need to tune the system. Now, the tuning of the system is again based on different criteria. So if the error is very large, a certain set of methods are used for tuning. Okay, so the values are changed differently. If the error is, let us say, medium, ranging between 30 to 60%, so again there are certain set of methods to tune. If the error is low, again there are certain sets. So depending upon the value, depending upon the performance of the system, we need to take a corrective action so that the system gets tuned at earliest, and then we can get the desired output. Why we need to do it at earliest? Because the system is tuned online. Okay, so when we are doing it online, the response or the response time is very much important. So that is why membership function tuning using performance criteria is one of the most important thing in adaptive fuzzy. Now, as I said, this is nothing but a performance based FKBC, that is fuzzy knowledge based controller. Why we are calling it performance based? Because depending upon the performance of the controller, we are going to take the corrective action. Okay, now what are the parameters that we need to, or before going ahead with that part, then let us understand the block diagram of what exactly we are going to do here. Okay, now when we are using this thing, we require a reference. Set point is nothing but the reference value. For example, we require a speed of 1500 rpm. Okay, so my reference value will be 1500 rpm here, and this is nothing but my actual output. Let us say that this is nothing but the process is basically a motor. Motor is rotating at 1480 rpm. So motor is rotating here at 1480. The output is how much? 1480, but my requirement is what? 1500 rpm. So this 1480 will be sent here. So 1500 minus 1480 will be the 20. So we will be getting an error of 20, which is sent to the controller. Now, similarly, what we are going to do is, the set point also is sent to the performance. So that means what? We want 1500 as the reference value for our system. So performance of the, what is the 100% performance? My set point is 1500 and my output is 1500. So my performance is what? 100%. We want the performance of the controller to be as high as possible. So now what we are going to do, you can see here the fuzzy controller. This is nothing but my FKBC block, fuzzy knowledge based controller, which is going to give the output depending upon the performance of the system. So in order to check the output whether the things are working as per the performance or not, let us say that it has given you with the output U. This output U is again fed back or checked by the performance measure. Now we know one thing, that the requirement was 1500 RPM. That means there was an error of 20. Okay, so there was an error of 20. So we required to increase the speed by 20. So what it has to do, this controller has to take a corrective action and tell that the voltage has to be increased by a certain value such that the speed should be increased by 20. Let us say that it has taken a decision and the speed increased, or it has given a decision to increase it by, it has calculated and it gives a 18 RPM ka speed. So but your requirement was how much? Increased by 20, but we have got it 18. So still what is the performance? Again there is an error of 2. So the performance is not 100% yet. So again what it will do, the adaptive algorithm will come into picture. It will tune the functions and again give the command to the controller that you need to increase the value by another 2% or 2 RPM. So again it will do that thing. It will increase by 2 RPM here, and thus what will happen now, here it is, or what it will do, it will see that it should be 1500. So this is 1500, the reference is 1500, the performance of the system is 100%, and your system works well and fine. This is how the system works here. Now what is, sorry. So what is that thing which we need to see here? So this is what is the block diagram approach. In this block diagram, the performance monitoring, okay, what are the parameters that a controller needs to look forward, or what we can say is what are the parameters it is looking forward for. The most important thing is, let us just take an example here. This is a 2 input 1 output type of system wherein our inputs are nothing but error. Okay, so this is what is the error which is going to come here, and the change in the error. Fine. So error and the change in the error are the inputs, and what is the output? Required change in the control output. That means what should be the change that has to be taken place. So error and the change in the error are nothing but the inputs to the system, to our fuzzy type of controller. Now what type of controller we are using here is a we are using a PD type of fuzzy knowledge based controller, that is proportional differential type of controller, which has been coupled with an adaptive system, okay, which in turn takes the performance of the system and tunes the parameters. Okay, so we are basically tuning the values of Kp and Kd such that our error becomes minimum and thus our performance is high. Now as we have seen that our inputs are what? The inputs are nothing but error and change in the error. What is our output? Output is nothing but the required change in the control output. So how much amount of change has to be done? For example, as we have seen, the requirement was 1500, but our output was 1480 RPM. So there was an error of 20. So you need our controller, PD type of controller, what it has to do? It has to tune the value of Kp, Kd, or it has to tune the parameters of our membership function such that the speed increases by 20. Okay, so that is what is our requirement. That is nothing but our control output. So this is nothing but our entire block diagram approach, what exactly or how exactly the system works here. Now, as I said, what are the parameters that it is going to observe? For example, what we are saying here, performance measure. Performance measure means what? It is going to measure the performance. So if we are measuring the performance, then we need to have what are the parameters that it should measure. Okay, so there are basically 6 parameters on which the entire system measures the performance. So the first parameter what it is going to measure is the average square error. Okay, so average square error. So first one is nothing but average square of errors. Second one is nothing but our average error. Third one is nothing but our absolute error. So square of the error is the first, average square. So average square of the error is the first parameter what it is going to see for performance measurement. Second is nothing but the average error. Third is nothing but the absolute error. Fourth is nothing but our maximum error. Fifth one is nothing but number of consecutive. Fifth one is number of consecutive variations in the control output, and the sixth one is nothing but N2, that is nothing but variation in the control output during the certain time interval. Okay, so these are the 6 parameters on which the performance is based. Okay, so it is going to measure. So we will be having 6 different fuzzy sets, wherein we will be having average square of error, average error, then absolute error, then maximum error, then is nothing but our number of consecutive variations in the control output and number of variations in the control output during a certain time interval. Okay, out of these, first 4 are very important because the performance, these are the first 4 which the system is going to focus on in order to tune the system. These 2 are not considered more, but when we are talking about any of the controller, these 4 parameters are the most important parameters on which the entire system is based on. Okay, next. So depending upon the values of the first 4 indices, an appropriate adaptive action is taken. So okay, so that is what I was saying here. Depending upon the first 4 values, it will take an adaptive action. So there are 4 different adaptive actions which it is going to take. So let us say that if the error is maximum, then there is a certain set of values it has to change. Or if the maximum, if average square of error is there is some change in the average square. So let us say that this is nothing but low, medium and high categorization again. So all these are categorized into low, medium and high. First 4 only. We are not going to consider 5th and 6th right now. So let us say that low, medium and high is there. So what we are going to do, if the average square of error is low, a certain adaptive action will be taken. If it is medium, then certain adaptive action will be taken. If it is high, then certain adaptive action is taken. Similarly for all other parameters. So this is what we will be seeing it now here. You can just see here. Okay, so in this case, I think we can see the cursor here. So everybody please focus on the parameters. Now, the 3 parameters what they have considered here. Error is basically this one, E, square of error and maximum error. So basically this is average error and error, they have taken it as a common one. So error, square of the error and maximum error. So these are the 3 parameters what it is looking for. Now, so if the average error is too large, okay, so error ka range, we know one thing, error can be either positive or negative. So ranging from minus alpha to plus alpha. So alpha can be either minus 100 to plus 100. Okay, so or depending upon our requirement or depending upon the application, this error range, alpha range can be set. Next, now if the error, let us just focus here. So you can see here adaptive action A, B, C and adaptive action D. Now when we do not require any kind of adaptive action, okay, if the error is, or what we can say, if the error is less than alpha, okay, if average error, okay, sorry, if the maximum error is greater than alpha, okay, sorry, if the maximum error is less than alpha and if square of error is less than beta, in this case no adaptive action is required. What does this mean? Suppose that our requirement was 1500, that is the reference value is 1500 and your actual system is working on 1500 RPM only. So in that case the error is 0. We need not go ahead with any kind of changes. So in that case we need not do any kind of adaptive action. Okay. Next, what about the adaptive action A, B, C and D? Now if the error is, let us just focus on this part. If the error is too large, okay, if it is greater than 0 means if it is very much large, then adaptive action A or B is taken. Okay, if the value is very much greater, adaptive action A or B is taken, depending upon whether error is above or below the set point. Fine. So for example, if error is greater than 0, greater than minus alpha, but less than plus alpha, okay, if it is in this range, then it will go to this one. But let us say it is not this. If the error is very much high, whether the error is above 0 or below 0, adaptive action A or adaptive action B is taken. So what is adaptive action A and what is adaptive action B? So let us just focus on this part. So we can see here, just zoom on this part. So this is nothing but adaptive action A and adaptive action B. Now what exactly the controller is going to do? The adaptive action A and B improves the controller performance. Now why we are doing this thing? We want to improve the controller performance. Now when the error is greater than 0, okay, so when the error is greater than 0, this is done. Okay, adaptive action A or B is taken. When we are talking, if the error is greater than 0, we are going to take the adaptive action A or B. Now, how exactly we are going to apply this adaptive action A and B? Now, what we are going to do is, this is going to modify the membership function. As our title itself says that membership function tuning using performance criteria. So we are going to tune our membership function. So membership function is nothing but the shape of the membership function. So we can see here, we have considered the error. So error is negative, okay, or positive. Fine. So if the error is negative, in this case, what we are going to do is, we can see here, this value has been increased. Okay, for a certain point where the values are negative. Okay, that is what we are going to do. We are going to increase the degree of membership. Fine. So this was our system and we have increased the value. So by changing this thing, what will happen is, the values, suppose that our answer would have been here. Now as it has been bulged, what it will happen, it will come on this part. So our answer will change a bit. So if there is a, what we can say, in this case, what is going to happen, here we are going to modify the membership function of the error. This, we have increased the value of error for the negative value. So we can see here, by increasing this thing, what we have done, we have changed our output. Okay, so this is what is an adaptive action A and B. Similarly, we can see here, the values are negative only in this first half. So what they have done is, the 50% of the region, wherever there is a 50% of this part. Okay, you can see here. So this is 0 to this value. So 50% is this part. So for the first 50%, they are changing it. Here also, for the first 50%, for the negative values, okay, in this part, they are changing it. Similarly, for here, they are changing it. Clear? So in this case, they have, if the error is okay, what they have done, they have decreased the value. Okay, so either by decreasing or increasing the value of a membership function, we can do this thing. So this is nothing but the adaptive action A. Fine. Now when we will apply adaptive action, so this is nothing but adaptive action A and adaptive action B. Next. Okay, so I think we have to go back again. So let us see when we will be applying the adaptive action C and D. So we can just see here again now. So we have applied adaptive action A and adaptive action B. That means what? If the error is greater than 0. If it is greater than 0, we are going to apply adaptive action B. But if it is not greater than 0, that means if it is a negative value, we are going to apply adaptive action A. So in adaptive action B, what we are going to do, in adaptive action A, the values are increased, whereas in adaptive action B, the values are decreased. Okay, now we'll come to the next part. Now if the square of the errors, okay, now what we have done, we have used this one. If the square of the error, you can see here, if the square of the error is greater than beta, or what we can say, if the square of the error is too large, adaptive action C is taken. Fine. So in this case, we can see here, if square of error is very much large value, then we are going to apply adaptive action C. Now, what exactly we mean by this thing? Again, the same thing. The adaptive action improves the sensitivity of the controller by sharpening the membership functions. Okay. For example, in this case, we can just see here again. Let us come back to this part. Okay. Now again, let us just see this thing. What exactly we mean by adaptive action C? Now, if the square of the error is very much large, what we are going to do is we are going to increase the, or we are going to sharpen our system. Sharpening the system basically means by either concentrating the system or diluting the system. What is concentrating the system? Square, very are concentrating the system. Diluting is minus, okay, raised to minus 2.5 and all such kind of. So in that case, we are diluting the system. Now we can check the this thing, adaptive action which has been applied here for error. If it is negative, so we are concentrating the system. We can see here the value has come down here again. So this dotted line we can see here. So we are concentrating our system, or in this case we are diluting the systems. So depending upon our requirement, these actions are taken. Now the last part, that is nothing but if the error becomes too large, okay, if our error is very much large, then we'll be applying the adaptive action D. Okay. Now here, so we can see here the maximum error. So in this case, if the error becomes very much large, that is nothing but the maximum error is there. In that case, we are going to use the adaptive action D. Now, what is adaptive action D? Again, the adaptive action D is nothing but similar to adaptive action C, wherein we are going to concentrate the system or dilute the system. So this is how we are going to work on membership function tuning using the performance criteria. So what we exactly can understand from this concept is, depending upon the performance of the system. So what are the parameters which we are considering for the performance of the system? Is nothing but average error, average square of the error, absolute error, and maximum error. So by looking at these parameters, we are going to take a certain decision to change our shape of membership function, or change the what you can say membership, or we are going to tune the membership function in such a way that our controller performs at its best. So this is what we say by membership function tuning using performance criteria. Okay. Okay, everyone. Thank you. Hello everyone. So we have already seen what is a gradient descent algorithm. Okay, what is basically we see that gradient descent algorithm is gradient. Gradient is nothing but either up gradient or down gradient. So in this case we have studied gradient descent. So means what? The value goes on decreasing in such a way that after certain point it comes to an average in this way. Okay. So what happens? Our value goes on decreasing in such a way that, so error, let us say initially is this one, it goes on decreasing. So error 1, error 2, such that after a certain point the error becomes constant, and this is nothing but my final answer. So what is our requirement? Let us say the error is 20% here. Then by using our method, gradient descent algorithm, what exactly do? It is going to tune the values in such a way that this is going to reduce to something around 5%. And it is going to come here at E6 something around 6th iteration it is going to take around 2%, and then E7th iteration it will be something around 1%, and then it remains 1%. If it is in our tolerance band, the system will come out of the loop, and that will be your final result. So that is what is a gradient descent. But the gradient descent method is nothing but an offline method. But let us say that we want to use this as an online method. So that is what is nothing but an online gradient descent method. Now, if we want to use an gradient descent algorithm online, then we require a reference. Okay, what do you mean by reference? See, let us just come to this block diagram wherein there is a set point. Okay, let us say that the set point is nothing but 1500 RPM. So what exactly? This is the process. Process is nothing but let us say that this is a controller which has been connected to the motor. Okay. So this is nothing but our process, and we have a, what we can say, the output of, let us say here, 1480 RPM. This 1480 RPM is fed back to the controller. So our set point is 1500, output is 1480. What is the error? Error is nothing but our, error is what? Error is nothing but our 20 RPM. Okay. So error is 20 RPM. Now the parameter has two inputs, what we can say, the error and the change in the error, and the control output U is nothing but the system. Now what is our FKBC, adaptive FKBC here? This is nothing but a feed forward controller is nothing but our FKBC, that is nothing but the controller which is going to take the corrective actions. Let us say that this was not there. What would have happened? This is going to take the reference. It is going to generate a signal that by speed has to be increased by, it understands the speed has to be increased by 20 RPM. So appropriately it will vary the value of a either P, PI, PID type of, we are using the controller. So it will vary the value of KP, KD, KD such that the value we are going to use we are going to get certain value which will be sent to the process. Now, it might not give you the 100% value. So that is nothing but again. So initially it was, error was 20%. So when it took a corrective action, the error came to 5%. Next again it will take a corrective action, it will come to 2% and so on. But this is nothing but what will happen in this, the time consumption is more. So what we are going to do here is we have a feed forward controller, okay, which is an adaptive FKBC block. So this is nothing but the brain given for this thing again. Okay, so this is a controller again, and we have a additional adaptive system. So depending upon the situation, it is going to take a decision. So you can see here, it has taken a certain amount of decision here, and then it is going to get the system, give it to the feed forward controller. Feed forward controller will come to know that you are going to get again an error of 5%. Fine. So what it is going to do, because the set point is again given to this thing, from here it is going to take this part. Now what is going to happen here? This understands that there is an error of 5%. So again what it will do, it will generate a control output U, which will be fed to the system. So this plus this will be in such a way that you will get a better result, and this is what is nothing but an online gradient descent. Okay. So this is how we tune the system such that our parameters are, we get the better results in a faster manner. So this is what is an online gradient descent method. Okay. So I think it is more clear now. So this is what is the system. Okay everyone. So, thank you.